Okay, this is what I wanted you guys to do here today. I know I'm not here. This is what we did, what we're doing during fifth period, and we just want to review what we did based upon our candle experiment. Our candle experiment, what we did is we found the heat of combustion, which is heat of combustion is measured in joules per gram. So we'd have to get units of joules, find how much energy is gained by the water, which is lost by the candle or any energy source we're using. And we'd have to figure out how many grams that our energy source, for example our candle, used up. And that's what we did when we went through the analyzing the evidence of our candle experiment. So if you get that out, we'll just review on page 248 of that document 1 through 4, I guess it'd be 1 through 6. 1 through 4 on the front page, and then turn to page 249, we'll do 5 through 6. So you should have that out, and we're just going to run through that, and then what you're going to get is an assignment for you to find a heat of combustion of a different gas, okay, or a different fuel source. So that would be the heat of combustion, and also we have what's called a molar heat of combustion, which is based upon per mole of a substance reacting, and its units would be in, I guess heat of combustion should be in kilojoules per gram, and the molar heat of combustion should be in kilojoules per mole. That's what we're looking for, kilojoules per mole. So we're going to go through the steps real quick. You guys follow along. You have similar setups that you should have showed. That's going to help you on this this other assignment. Okay, so number 1, we had to change milliliters of water to moles, or I'm sorry, 2 grams. Now for water, it's pretty easy because the density of water is 1. So if you remember, and we're going to go through this real quick, that we had 100 milliliters. And what we did is we said for every 1 milliliter we have 1 gram of water because that's the density. So that would get you 100 grams of water. So that's the first thing we need to do. We need to have our value in grams. Okay? Number 2, what we were asked to do is find out what the change in temperature was. So let's say that we started out at beginning temperature was 8 degrees Celsius. That was beginning. And our ending temperature of our water that we're heating up was, let's say, 12 degrees Celsius. So we take the difference between those two. The difference would be 12 minus 8. And that would get us 4 degrees Celsius was the change in temperature. So why do we need to know those two bits of information? Is so that we can do number 3, which is find the heat gained by the water, or thermal energy gained by the water. Okay, if you remember, we'd use this equation. That would say heat, and that would be in joules, equals the change in temperature times the specific heat of water, which says for every 4.184 joules, that's what the energy is going to need to change 1 gram of water, 1 degree Celsius. So that would be the units. We haven't done that, but I'm going to show it to you anyway. And then you multiply it by the mass of the water, which we found in step 1. Okay, so our change in temperature, what I found was 4 degrees times 4.degrees Celsius on that. 4.184 times 100 grams. Okay? Now you probably would have done this already, but just to double check your work, if you want to look at that, didn't have time to do it because you were behind and didn't get things written down, now's the time you can do it. We get an answer that's 1,000, and we're going to round it. We're going to say 1,700 joules. All right? So that's step 3. Step 4 then is to find out what our change in our weight of our candle would be. So let's say, my example, we started out with 8.13 grams beginning, and the ending value of how much fuel that was used up was 8 grams. So if we subtract those two, we get 0.13 grams of candle burn. Okay? So 0.13 was burned. And so we're going to use that to find our heat of combustion in number 5. So if you turn your page over, first thing they ask you is number 5 to find out what the heat of combustion would be. So we would take our 1,700 joules divided by our 0.13 grams. And again, this is just making up some numbers. You guys have actual numbers. And I get 13,080. So I'm just going to make it 13,000. And that'd be joules per gram. So that would be 5A. Okay? Then in B, what we would do is we would use this conversion to change it into kilojoules, because we don't want to deal with such big numbers, 13,000. We want to reduce that a little bit. So then we would take, in B, we would take that 13,000 kilojoules per gram, or I'm sorry, that'd be joules. We haven't got the kilojoules yet. Joules per gram. And what we did on that step, remember, we said there's 1,000 joules for every 1 kilojoule, and that got rid of joules, and then with the kilojoules per gram. So kilojoules will be over grams. So I got 13 kilojoules per gram. That's the heat of combustion. In my example, anyway. And on number 6, we were supposed to change that into moles. So this is the heat of combustion. Okay. Again, this is review what we did yesterday, just to make sure that we're still on task, knowing how to do these type of problems. Then on 6, you're going to take that 13 in your number, what you would have taken, 13 kilojoules per gram. If you remember, our candle had a molecular mass of C25H52. And so when we take 25 times 12 and 52 times what hydrogen would be, what we would get is an answer that would be 352.77 grams per mole. So then what we would do is we'd say for every 352.77 grams, I have 1 mole. So grams cancel out, and I end up with kilojoules per mole. So when I do that, I get 13 times 352.72. I get an answer that would be 4,585 kilojoules per mole. You will have something different than what I have, but I'm just using this as an example. And that would be your answer for 6. Okay? So, now that I've taken about 10 minutes to do that and show that to you, then you're going to do the same steps. And go through the same steps in which to do the sample that the sub's going to go ahead and give out to you now. When you're done with this, I would like everybody to hand that in. I will leave a key for the sub, and then if there's a step you want to see if you're doing right, or that, you can compare it to that key, but you won't look at the whole key all at once. If you got a step or something that you might want to do, you can come up and look at it, see if you're doing it right or not. But you want to basically use this as a guide, this sheet that you have in front of you, as a guide to help you out.